Welcome to Ask and Learn.
All right. So this question is talking about that we have the speed of sound at 20 degrees Celsius, so temperature is close to 20 degrees Celsius, and the speed is 343 meter per second, and the lowest frequency sound wave that human ear can detect is usually 20 hertz. So lowest frequency sound wave is 20 hertz. So what is the wavelength of such a sound wave? So we're trying to calculate lambda, so we don't know. So the first thing to ask yourself is that what is the relationship between the speed and lambda? So we know that, or we can just figure it out based on these units, right? So this hertz is also per second, so that is 1 hertz. So this is also cycles per second. Okay, so we know that uh, speed, or let's just say c is equals to half lambda, where the unit of frequency is cycle per second, and lambda is wavelength, and that is in meters, right? So this c is equals to speed. Okay, so then we can calculate the wavelength by making the lambda the subject of the formula. So lambda is equals to c over f, right? So the speed that we are given is 343 meter per second, and the frequency is 20 hertz, which is 20 cycles per second. So that's 20 cycles per second. So then whatsoever this is will give us uh, the wavelength, and this will be 343 divided by 20. So this is 17.15 meters, and that's the answer. And then the question is also, so this is the answer to the first part. So this is A. We are looking for the wavelength. Then the second part is about what would be the frequency of the electromagnetic radiation with the same wavelength. So here we are looking for frequency with the same wavelength. So wavelength here is 17.15 meters, right? So we're told that this is an electromagnetic radiation. So how do we determine what the answer to this will be? So what we need to do is to first understand the situation that we are dealing with. So here we have the frequency. We're looking for the frequency, and then we've calculated the wavelength. So what equation connects the frequency to the wavelength? So what we will do here will be to say that f, which is the frequency, is equals to c over lambda. Okay, so because it's just the same equation we have here, what we just did is to make f the subject of the formula. And in this case, if we're talking about electromagnetic radiation, that is, more or less light. And the speed of light is 3 times 10 raised to the power 8 meter per second. 3 times 10 raised to the power 8 meter per second divided by the wavelength is 17.15. meters. So what would this give us? 3 times 10 raised to power 8 divided by 17.15. So this is 1749271.11.1749271.37. Well, if we look at this, the answer to this is going to be uh, in hertz, right? So this will be, we can approximate this to be 17.5, or let's just make it 1.75. So this can be 1.75. This is 1, 2, 3, 4, 5, 6, 7 times 10 raised to power 7 hertz. And that's the answer. And what kind of electromagnetic radiation would this correspond to? So to determine what this will be, we just need to check the electromagnetic spectrum and figure out which one is in the range of 1.75 times 10 to the power 7 hertz. Okay.